Before we introduce the Java platform, how about answering a very basic question? What is a PC? Take your time. The dictionary definition of computer is that it is an electronic device, capable of performing computations. It has many peripherals like a monitor to display data, keyboard to accept user data, and memory to store information. But the heart of the computer is its processor, which does all the thinking for it. Coming back to our definition of computer, you may have noticed the keyword electronic. Thinking of it, if computer is an electronic device, how can it understand and display text, images, videos, and other rich media information? Well, a computer understands only electronic signals, where a 5-volt current represents a binary 1, and a 0-volt current represents a binary 0. Your PC is continually bombarded with these electronic pulses, which it understands. 8 bits of such signals are grouped together, and text, numerical, symbols are identified by unique patterns of these 8 electric pulses. For example, symbol, hash, is represented by pattern 10101010. Instruction to add two numbers is represented by pattern 10000011. This is 8-bit computing. Current-day processors are capable of understanding and decoding 64 bits at a time. Suppose you are asked to write a program to add two numbers, say add 1 with 2. Assembly language is the most elementary form of software development languages. Your code to add two numbers in this language would be like: store number 1 at memory location, say A, store number 2 at memory location, say B. Add contents of location A and B. Store results. The way you feed this code to the processor would depend on the PC you are using. Back in 1950s, when computers were huge and consumed great deal of power, you would convert your assembly language code into corresponding machine code of ones and zeros, using mapping sheets, and punch the machine code into punch cards to feed to your computer. With advancement in technology, input and output devices were invented. You could directly type your program into the PC, and using a program called assembler, convert it to corresponding machine code, and feed to your processor. That apart, you will also have to make calls to operating system provided functions to display output of code. With advancement in software development languages, this entire assembly code could be shrinked into just one line, printf1 plus 2. A software called compiler is used to convert your C language code into assembly code, and the assembler converts it into corresponding machine code. Though present-day compilers come bundled with assembler, and can directly convert your higher language code into machine code. Now, suppose Windows operating system is running on this Intel processor. Combination of operating system plus the processor is called the platform. The most common platform in the world is the Windows and Intel platform, called the Wintel platform. The other popular platforms are AMD and Linux, PowerPC and Mac OS X. Now, with change in processor, the assembly instructions will change. For example, the add instruction in Intel may be called addition for AMD, or math add for PowerPC. And obviously with change in operating system, the level and nature OS level calls will also change. As a developer, I want my software program to work on all platforms available, to maximize my revenues. So I would have to buy separate compilers which convert my printf command into the native machine code, but compilers come expensive and there is a chance of compatibility issues. Enter Java language. The code to display addition of two numbers in Java is system.out.println 1 + 2, saved as .java file. Using the Java compiler, the code is converted into an intermediate code called the bytecode. The output is a .class file. This code is not understood by any platform, but only a virtual platform called the Java Virtual Machine. This virtual machine resides in the RAM of your operating system. When the virtual machine is fed with this bytecode, it identifies the platform it is working on, and converts the bytecode into the native machine code. In fact, while working on your PC, or browsing the web, whenever you see either of these icons, be assured the Java Virtual Machine is loaded in your RAM. But, what makes Java lucrative is, that code once compiled can run not only on all PC platforms, but also mobiles, or other electronic gadgets, supporting Java. And Java is absolutely free to use. Hence, Java is a language, as well as a platform,